Hello everyone. In this video we will begin to consider topic 2.1, motion, and in particular we will disambiguate position, distance, and displacement. Alright, so the study of motion begins with the question sort of how do objects move, and it's important to recognize what exactly it is we're going to describe and quantify in this particular subtopic. So in all of 2.1, which is pretty sizable, we're going to study kinematics, which is the study of motion, and it's a formalized way of describing how objects move. Throughout this particular subunit, we won't really be describing what makes them move or how do we know or anything like that, more just learning to speak physics, learning to apply physics vocabulary, concepts, and mathematical tools in order to analyze motion. And in order to do that, we need to be careful about what we mean by particular terms. And three terms that we're going to introduce in this little video are position, displacement, and distance. The first thing to recognize is that position or location is the answer to the question where you are. So where are you? Whatever your answer is to that, in whatever space you're in, is your position or your location. And position or location, perhaps surprisingly, is a vector, and it's written usually with an x, although there are other variables that are used for position vectors occasionally. And it is a vector relative to a coordinate system. So the way to think about it is your position in any sort of space can be put onto a coordinate system. So you're located here, you're located here, located here. And in that coordinate system, because of the coordinate system itself, that location has a direction. It's actually not just a spot, per se, but relative to the origin, that spot is characterized by a distance away from the origin, here, sort of a length away from the origin, and a direction compared to that origin. And that is the nature of position considered as a vector. It's relative to that coordinate system, okay? And if I move the coordinate system around, this is important. So if I move the coordinate system around, I like shift this over here or somewhere else, and then the location stays the same, but how that location is defined and the value that it's given is going to differ. So this is perhaps a little bit easier to see in one dimension. If I have a single dimension here and a location somewhere along that particular dimension, let's say this is 0 and my location is right here. Okay, I'll mark that with a red arrow. Then even if I move my coordinate system, so this blue arrow here, I can move it left and right, my position stays the same, but how I might describe that position compared to my 0 will change. So right now this could be, for example, positive 3 meters. But if I take that coordinate plane and I move it this way, right, my red arrow didn't change, but I just have a new 0, then that position would be described in this coordinate plane as perhaps -1 meters here. And you can see how it's signed. It's relative to your chosen 0. Right? So that's what position is, and that's why it's a vector. Displacement, on the other hand, is the change in the position. Okay? Delta x. So displacement is the change in the position. So, for example, in one dimension, if I go from an initial position over here of, let's say, 13 meters, and a final position right here at, let's say, 8 meters, so notice that both positions are vectors. It's positive 8 meters for that initial position, and positive 8 meters for that final position, then my displacement will be the change in the position. That is, my final, positive 8, minus my initial, positive 13, giving me a displacement of negative 5 meters. That, I want you translating displacement as the change in the position in your head. The unit of displacement is the meter, and it is a vector quantity. It has both magnitude and direction. And displacement is a concept we're going to use quite a bit. So translate displacement in your head as change in position, delta x. Now, in the IB uses the variable s to indicate displacement. But don't be confused here. S is not a position. S just means the change in the position, delta x. This is a bit of confusing and perhaps not ideal notation, but it does simplify some equations later, so we're willing to live with it a little bit. But it is important to recognize that every single case of displacement is a change in a position. It's a delta, a final position minus an initial position. So how does that work in 2 dimensions? Well, imagine you're at this location here. This is your initial position, and you travel here. This is your final position. Okay, notice the initial position vector is given by xi, and the final position vector is given by xf. So your displacement is the change in the position. It's the final position minus the initial position. A way to analyze the final position minus the initial position is to take xf and subtract the initial position, okay? Or add the negative of the initial position. So we reverse this vector, right? Reverse its direction and add it tip to tail to our final position here. So that's the final one plus negative the initial, giving us a delta x, or a change in x, that is a displacement, looking like this blue vector here. So if we started out here and we went here, then somewhat predictably, the change in the position, the displacement, is represented by that vector right there. And so you never want to forget that displacement just means change in position. Okay. And finally, we have the concept of distance. Distance is a term that means the absolute value of the displacement as a vector. It is a scalar itself, and is often given this symbol here just to indicate the magnitude of the displacement, or it's given another name like length or width or height, for example. And the definition of distance is the length of the path followed, okay? It's the length of the total path followed, and it can be the magnitude of a displacement. So consider trip A to B to A. So here's point A, here's point B, here's point A, and imagine you took a trip from A to B and then back again. And the distance between them was 2 meters. Then the total distance traveled on your journey is 4 meters. But the total displacement, or the change in the position over the whole journey, was 0 meters. Imagine you just went from A to B. The total distance you travel is 2 meters, but the displacement is positive 2 meters. What if you go from B to A? The total distance you travel is 2 meters, but the displacement is negative 2 meters. Okay, so that's the difference between the concepts of distance and displacement. And remember that displacement is signed. That is, it has a direction, either from A to B or from B to A. Now, sometimes the word distance is ambiguous. Sometimes we mean just the magnitude of the displacement. And sometimes we do mean the total path that might be followed on a journey from A to B. And it'll be up to you, looking at the context, sort of which is meant in any particular circumstance.